Hey guys! Hey you laboon! How's it going? When the live starts, I have a question to ask Mr. Duncan. Oh, this is exciting, Atia. It's very exciting. Year 10, you are absolutely right. I did not put the excess reagent questions online. I do apologize. Although, do you know what? Oh, that's awkward. Specifically, one very special question. Okay, Atia, go for it. Hit me. Oh, it's gone off. There we go. Sup, Zach? Sup, dude? Bruh. I just did that live on YouTube. Oh, I totally forgot this was live on YouTube. Oh, no. If our class all turned into worms, would you still teach us chemistry? Yeah. Right, let's do the register. Let's do the register. Do the register. Laura was first in the house. Sup, Laura? Yo. Right, there is Laura. Well, hang on a minute. I have Imani. I've seen Imani. Seen Imani. Seen Zach. Seen Sophia. Is Tiffin? Is Tiffany in the house? Tiffany's in the house. Do I have Kayla? Anyone seen Kayla? I know that she's struggled with her internet. She's not here. Mel? Has anyone seen Mel yet? Sup, Lynn? Sup? Anyone seen Mel? I haven't seen Mel yet. Libby's in the house. Anyone seen Audra? I've got Atia. I've got Ananya. Caitlin? Anyone seen Caitlin? Haven't seen Caitlin yet. Dom's in the house. Ryan's in the house. Lynn's in the house. Libby's in the house. How Ping, I believe, is in the house. Where's How Ping? Where are you, How Ping? How Ping, hello. British people be like, right, what's all this then? Oh, Kayla, hello. And Mel's in the house. Love it. Caitlin's here. Mel's here. Kayla's here. Amazing. It's a good job. British people be like all, I'm going to hide that one, Imani. Actually, no, I'm not. Yeah, whatever. I didn't say it. Well, Watching Spy be like Peter. I don't get it. You guys, you've lost it. You've all gone mad. Has anyone seen Audra? She's the only person missing now. Has anyone seen Audra? I don't get this worms thing. What's this worms thing? I've just had it asked me twice. Is it Lynn's asked it too? I'm so confused. Guys, you're so confusing me. What? Anyway, I'll mark Audra as missing. Okay. She's sleeping. Okay. Right, guys, let's crack on. Guys, we finished calculations, and yes, I'm suddenly realizing you're staring at my forehead. Hello. That was super creepy. Sorry about that. I forgot. Audra watched Vampire Diaries all night last night. Right, let's move on. Guys, we finished calculations. And I didn't post the homework. So you've had a night off. So I will post the homework. I'm actually going to just do a couple more excess reagent calcs. I'm going to do a few more. And then what I'm going to do is I'm going to do a summary, and I'm going to go through all of our calculations types that we started with at the beginning of the topic. Yeah, we're just going to run all the way through them. And yes, I am busy making your test on Google Forms. I have written all the questions. There are 20 questions. I finished it today. I'm just filling in all the answers. And I'm going to talk to you a bit about that in a minute. And I'm not going to do it tomorrow. Tomorrow I'm going to start the next topic. Don't ask me what it is for the life of me. But your test is on Monday in our lesson. So you're going to have 1 hour to do 20 questions. Yeah, and I'm going to watch you guys do it. I think I'm going to do it on Hangout instead of YouTube. I think I'm going to do that. Okay, let's share screen. Share screen. We're just doing a summary today. So we're on that one. Hide. There we go. Okay, let's crack on. Crackage. Okay. Okay, dokie. No! Oh no! Oh no! You saw nothing. Oh, that's a disaster. 10A. Oh no. Okay, so. Oh no. Was that the test? No, Laura, it was not. It definitely was not. No. No. Oh no. Yeah, no, it wasn't. No. So, so here are our calculation types. Can I ask you guys not to look at it? It's taken me ages. I've had to handwrite it. Please, please, please. It'll ruin it. That was really, really unfortunate. It's really unfortunate. Do you know how long it's taken me? An hour and a half to do that. I don't like it. Okay. Right. Excess reagents. Don't like it. Okay. We did excess reagent. We won't. Got a feeling some people. So, okay. Just nice to review all of our calc types. So these are our types. Every single one of these types is on the test. So we had number 1, we had AR, MR, yeah, and then MR, of course, is split into RMM, which is actually the same as MR, but then RFM, but that makes no difference, even though this one's ionic, yeah, and this one's covalent. We know this, yeah. So I've actually tried. It's too small. Yeah, I think I may have stuffed that up. Whatever, it's done now. Broom moment. I don't know what that means either. Okay, so what I've actually done is the test that you guys have got, I've organized it in the way that I've taught it. That's what I've done. Yeah, so we did AR and MR. Then we followed it up with equations. Yeah. So the equations one it's been a bit tricky for me to do on a Google form. I'm just going to quickly talk to you about this. Yeah. I haven't actually given you any word to symbol ones. I figured. Sorry, I've skipped one. Sorry. Second one is formulae. Yeah, we've got a formulae question followed by an equations. Yeah. I've also realized a couple of hiccups with the Google form. You can't do subscript. So if you were going to do something like, I don't know, if you were going to write down iron 3 oxide in Google form, that would translate to that. Yeah, I can't do anything about this. You can't type in subscript. Yeah, but you can do capital letters and lowercase, so that will count. Yeah, but the numbers will just be big like that. I do apologize about that, folks, just so you know. Yeah, so formulae, words to symbol. Then we've got equations. You're going to have a balance equations question. Yeah, so if we had something like, I don't know. If you had something like this, yeah, on Google form, something like this, yeah, it'll have boxes here like that with question marks in, and it will tell you to input the ratio. So you would put 2, 1, 2. That's what you would write down in your answer. Yeah, no spaces. Just thought I'd throw that in there. Yeah, so you've got balancing equations. Yeah. And then Question 4. I think we then walked into moles at that point. No, we didn't. Then we did percentage composition. Percentage composition. Yeah, that one's easy. Then we had moles. Yeah. Now you get moles in A gases. No, I'll put solids. Yeah. Anytime you see grams. Yeah. Fix that there. It actually can be solids, liquids, and gases, just so you know. But it's really just anywhere where you're given grams. Yeah. Because if you're given grams, then you're using grams over rams. Yeah. Number of moles is grams over rams. And then you had moles in solution. So all of these are on there. Yeah. This is what you're looking for out here, guys, is centimeters cubed, moles per dm cubed. Yeah. Those are the ones you're looking for really there. Those are the units that tell you when you're using your equation. Number of moles equals C times V over 1,000. Yeah. Next, C, of course, is gases, which is really easy. It's just number of moles. I'll just put centimeters cubed or dm cubed. Yeah, and we've got number of moles is V over 24 if I'm in dm, and then V over 24,000 if you're in cm. Yeah, all that jazz. Cm cubed. Yeah. Do we need to know state symbols? Yes, some of them do require state symbols, and it says so. It's not complicated. All acids are aqueous. Yeah, all salts will be aqueous except for the insoluble ones. Don't worry about that. It's not complicated, Libby. Don't worry. It's really easy. It's very straightforward. After you got to moles, we then got to moles and we then did reacting masses. Yeah. Reacting mass calcs. And these are the really hard ones at GCSE, the ones everyone struggles with. After the reacting mass calcs, we then did, we've missed empirical formula. There we go, empirical formulae. The questions on the test may not follow this exact structure of that thing, but it's very close. Empirical formulae, and then we did water of crystallization, water in crystals, yeah, water of crystals, and then we did excess reagents. And that's it. That is all your test, reagents. There are 20 questions. There are 20 questions on the test, and it shouldn't take you more than an hour. And as I said, I'm going to give it to you on Monday. Oh, your test is on Monday, and I'm going to send it out to you at the start of the lesson. I'll do the register, and then I'll send it out to you guys on Monday, period 2, and you'll do it with me. And yeah. Cool. So, okay. I just want to cover a couple more excess reagents. I also really like to do some extension questions. So what I'm actually going to do today is actually have a little a look at some A-level questions as well. We're going to do a couple of excess reagents and then have a look at a couple of extension questions, just to show you that the process is always the same. It's always nice to do that. Okay, so excess reagent questions. Excess reagent. Right. So let's keep it simple. Let's go for Na. Na plus Br2 goes to NaBr. Balance my equation. Yeah. Going to give you 40 grams of him and, I don't know, 10 grams of him. How much sodium bromide will I make? So this here is an excess reagent question. Now, students often say that they never know how to recognize an excess reagent. Well, the way they always recognize it is because they give you grams of two things. What that means is one of them is not needed. One of them will be in excess, and you're going to ignore that one. But what that means is we just have to run moles on both. That's all this is. Yeah? So what I'd like you to do, folks, is pause the video now, and see if you can calculate who's going to be the excess and therefore the amount of sodium bromide. If you're not 100% sure on it, and I understand that you haven't had any questions to solidify this, if you want to watch my first one, you're more than welcome. So first thing is, step 1 in any chemistry calculation is get to moles. Yeah, we don't work in grams, we work in moles. So we need to do number of moles is grams over rams. How much does sodium weigh? We find sodium on the periodic table. It's 11 and 23, and the number that matters, of course, is 23. So we're going to do 40 over 23 grams over rams, and I get 40, turn my calculator on, divided by 23, and I get 1.74 to 3 sig fig. Yeah, moles. Next, grams over rams. What does bromine add up to? Find bromine on the periodic table. See if we can find bromine on the periodic table. There we go. Bromine is 80. So a molecule of bromine is therefore going to be 160. Yeah, so 10 over 160. This one's going to be a very straightforward one. 0.0625 moles. Right. The next step in any chemistry calculation is to write down ratios. And it's a 2 to 1. Now, even though this, so at this point, I want to find out who's in excess. So I'm going to cover somebody up. Doesn't matter who I cover up. Cover somebody up. Yeah. And then use the ratio and go, right, I'm going to times that by 2. So times that number by 2. And I get 0.125. And the question I now have is, do I have enough? And the answer is, I have got way more than I need. So that one is in excess. And I would simply write down the ratio and then put 1.7 is greater. That's it. That's a GCSE. That gets you all the marks at GCSE. There you go. Right. So since this one is now limiting, this one's the one that now matters. Right. Now I use the ratio again. So it's a 1 to 2. Double it times by 2. Did that already, which gives me 0.125 moles of sodium bromide. How much does sodium bromide weigh? Sodium is 23 plus Br at 80. So that's going to be 103 times by 103. And I am therefore going to make, to 3 sig figs, I'm going to make 12.9 grams. There we go. So there's my final answer. Yeah, the process does have a fair few steps in it. I do understand this. This is why these are all level 8-9 questions. Yeah, level 8-9. They're all at the top upper end. That most students in the UK wouldn't be able to do these. Let's go for question number 2, folks. Let's go for question number 2. Question 2. So what I'm going to do, let's do lithium plus water goes to lithium hydroxide and hydrogen. Balance the equation. There we go. Right, I'm going to add 10 grams of lithium and 10 grams of water. Right. Is greater than, yes, it is. Yeah, why is it? I think it's meant to be 0.12. No. Oh, I see what you're saying. You're saying, okay, I understand what you mean. You're saying that this is, okay, you're saying that that is greater than 0.12, so therefore it's in excess. Yes, but, Libby, you're absolutely right there. Yeah, but actually, annoyingly, it's not. Yeah, this is where Edexcel fall down here with the marking scheme, because what I am actually having to do is compare these two numbers. Yeah, they're wanting me to tell them that the amount of sodium is in massive excess to the bromine. Yet we need to compare. It's a very good question. This is where Edexcel's marking falls down. But I do understand what they're doing. They're comparing sodium's moles, sodium moles versus the bromine moles, and they're saying that this is in massive, much larger, therefore it's going to be in excess. I know that seems odd, and I agree with what you're doing. They probably would sting you, actually. Don't know. That's fine. Well, I know they probably would, actually, but don't worry about it. You kind of, the step, do you know what? I'll actually be a bit more descriptive about my steps this time. I'll run the description over here. Describing my process. So the first step I'm going to do is I'm going to get to moles. I have been given 2 masses. So one of them's got to be in excess. So I'm going to go moles is grams over rams. Yeah, we know this. We always write down that equation. Yeah, grams over rams. What does lithium weigh? 7. There it is. Yeah, so over 7. What does water weigh? Everyone in this room knows what water weighs by now. Weighs 18. Yeah, so 10 divided by 7 gives me 1.43 to 3 sig fig. And then 10 divided by 18 is 0.556 to 3 sig fig. Right, now what I do is I now go ratio. Yeah, you always do this in this particular fashion. Yeah, the ratio is 2 to 2. Oh, that's nice. And then we compare moles that I worked out. So I'm now going to compare him and him, and I'm going to say, therefore, 1.43 moles of lithium is greater than the 0.556 moles of water of H2O. Therefore, this one is in excess. Yeah, that's the process. Yeah, and I didn't have to, the great thing is the ratio made it so easy. Yeah, I didn't need to do that stupid cover somebody up because they were the same. Yeah, so what that means is this is limiting. Let's work out the mass of hydrogen. Yeah, the mass of hydrogen, of course, is in a 2 to 1 ratio. Yeah, so I'm going to divide that number by 2. 0.555555 divided by 2 gives me 0.278 rounded, keeping the number on my calculator now. And then what does hydrogen weigh? Hydrogen weighs 2 because hydrogen on the periodic table is 1 and 1, but it's in a pair. Yeah, so hydrogen weighs 2. You learn that one too. Times that number by 2, and funnily enough, I get 0.556 grams of hydrogen. Winner. There we go. Fun games. So you're always ignoring the excess. Yeah, whoever's in excess, you just go, oh, he's in excess, ignore, use the other guy. Let's go for question number 3. Q3. Q number 3. Did you get it? Q3, like Q up in Q. Okay. Let's try and do an awkward ratio one. Let's try and do an awkward ratio. Hydrogen plus oxygen goes to water. I'm just trying to keep simple equations here, folks. 2 and 2. I'm going to get given 40 grams of him. I don't know why I'm sticking with 40. Let's just stick with 10 each time. Let's go for 25 grams of each. No, let's make it awkward. 25 grams and 250 grams. That's a good number. I like it. Right. Step number 1, get to moles. We always get to moles in chemistry. Over 2 over, what does oxygen weigh? Oxygen is 16 on the table. It's in a pair, 32. Right. 25 divided by 2 gives me 12.5. 250 divided by 32 gives me 7.81. They're relatively close. The ratio is going to matter, though. Yeah, next thing is the ratio. Now, the ratio is 2 to 1. Right, I now need to do my cover-up trick. Yeah, so I'm going to cover somebody up. Let's cover somebody up. Let's make him disappear. Right, so I need the ratio, though. So the ratio is 2 to 1, and I've got 12.5 moles of hydrogen. If it's a 2 to 1, I'm going to divide it by 2. So I needed 12.5 divided by 2. I needed 6.25 moles. How much do I have? Now compare these two numbers. And the answer is, if this was needed, yeah, and I've been given 7, I've got more than I needed. This one is in excess, so we ignore it. Yeah, isn't that funny? Most students would assume that the 12.5 was in excess, but it turns out it's not. The oxygen is the one I've got too much of because of that ratio. Yeah, that's why this is awkward, guys. That becomes a level 9 at GCSE. I love 9. By the way, just to let you know that this is a grade C at A-level. It's nice to always know that. Yeah. So, right, the person I'm going to use is him. Going to use him now. And the ratio is 2 to 2. Oh, isn't that lovely? So I'm going to make 12.5 moles of water. And of course, water weighs 18. Times that number by 18. So 12.5 times 18. Times 18. And I'm going to make, isn't that fascinating? I'll put times by 18 there. I'm going to make 225 grams of water. Yeah, because I'm going to ignore the excess and use the limiter. Yeah, I know it's hard, folks. Let's go for another one. Keep it easy. I'm trying to scroll up, it won't let me. Question 4, Q4. Q number 4. 7 point what? So you cannot write 7.8 is greater than 12.5. No, that's the point, because it's not. That's exactly right, Libby. You can't write that because that literally isn't right, is it? You can't do that. That's why you have to write down, yeah. Oh, I've missed it, haven't I? Yeah, I've missed it. Oh, hang on a minute. You have to compare the two of them. Yeah, the excess. Oh, isn't that awkward? Yeah. You're absolutely right. What a nightmare. Yeah, you're actually going to write down that the 12.5. Yeah, oh, that's awkward. You can't do that, Libby. You're absolutely right. So you cannot write down. You're absolutely right. You can't. You would just write down 7.8. Oh, but you can't. If you do your little clever trick, Libby, if you do 7.81 is greater than 6.25, yeah, it's awkward, isn't it? It's awkward. You wouldn't do it. You would. You could multiply 7 by 2 to give you 12.5 by 2. Yeah. No, you wouldn't. You would just write down. They will know what you mean. You're right. You would actually have to write down. Yeah, that's you would. Yeah, Oh my, that's really annoying, isn't it? Yeah, I totally understand the limitation of this, folks. But with the ratio, that it makes sense. Yeah, I know that seems mad, but that's what they'd want. Oh, that's really awkward. I apologize. I don't really know how to deal with that. I do. I'd write down that. Annoyingly, that's what I would write down in my exams with the ratio. As long as the ratio is that. I mean, I would actually follow this exact method in my exams. Just let you know. I'd literally be showing that. Maybe not with the heart, although I probably would actually do the heart because I'm super nerdy. Awkward. Let's just move on, Libby. Orcs. Awkward. I wouldn't do it. It's really awkward. Anyway, moving on. You guys you have not answered my question at all. Let's go for another one. Oh, blimey. Aluminium plus oxygen goes to aluminium oxide. Balance the equation. Oxygens are going to be the problem. And 4. There we go. It's going to be awkward. Let's go for, I don't know, 100 grams of that and 100 grams of that. Right, folks, how much aluminium oxide do I make? Yeah. So pause the video, have a go, and then watch the video to check your answer. Right, steps, moles. As soon as I see 2 masses, I know this is an excess reagent. Yeah, moles, grams over 27, over 32 for oxygen. We get used to these numbers after a while. So over 27 gives me, 3.70 moles. And then we go 32 divided by, 100 divided by 32 gives me 3.125. Oh, the ratio is awkward. Oh, Libby's not going to like it again. It's a 4 to 3. Right. So cover somebody up. Okay. If I've got that many moles, of oxygen, I need to use my ratio, divide by 3 to get it to 1. Yeah, and then times by 4 to get it to 4. 3.125 divided by 3 times by 4 gets me to 4.16, 4.17. Right, check it, compare it. Right, do I have enough? The answer is no. I need, that's how much I needed. This is how much I have. So this is the limiter. This is limit. Yeah, he's in excess. Yeah, he's in excess. We're then going to compare. Yeah, so that's the limit. So we're going to do, and that is a nightmare. 3.7 is smaller. Oh, nuts. Yeah. When ratio used. There we go. How about that, Libby? You happy with that? It's not funny. So that's it's funny that you'd expect the bigger one to be in excess, but it's not. Yeah, right. So the limiter is what you use. So I'm now going to use him to work out him. Yeah, what's the ratio? 4 to 2. That makes things a little bit easier. So 3.70 divided, the ratio is a 4 to 2. So I'm going to divide that number by 2. Gives me 1.85 moles. Multiply that by aluminium oxide. 27 plus 27 plus 16 plus 16 plus 16. 27 times 2 plus 16 times 3, 102. Multiply that by 102. 1.85 times 102. And I get a mass of, final answer, 188.7. If you're going to give 3 sig fig, 189. Final answer in grams. There we go. I refuse to write it. Oh, Libby, you're amazing. Oh, you're absolutely right. You write down whatever you like, Libby. You write down whatever you like. I don't mind. As long as you have, just to tell you where the marks come from, ratio, moles, and then the comparison, you'll get it. I don't think they'll compare. I don't think they'll be bothered on what comparative numbers you use as long as they're correct ones there. Yeah, so don't worry. It's good. You realize, by the way, that these are hard, folks. You know, these are the last calculations, the very last ones. Are you ready for question number 5? Q5. Q number 5, dude. Q number 5. Right, let's go for nitrogen plus hydrogen. On the chat, folks, can somebody tell me the name of this process? Give me the name of the process on the chat. See who's still here. See, I want everyone to post a name. Everybody. Just to see if I've got 14 people watching. Yeah. Let's see how long it takes for all those to start just appearing on the chat. There's quite a big delay on this one, actually. Okay, right. I'm going to do, I don't know. 4 kilograms of that and 0.5 kilograms of that. Reversible. It's the Haber. Yes, reversible reaction. No, the name. I love that, Mel. Oops. Lynn, oops. No, wait, nope. It's called the Haber process. Or Haber. Yeah, Fitz-Haber. Yeah. It is reversibly right, but its name is the Haber process. Very famous reaction, most important reaction in the history of mankind. Right, step number 1, get to moles. Yeah, I shouldn't call it moles until it's Christmas. Goes both ways. It's so true. So true. Does indeed, Zach. It does go both ways. It is reversible. But the name is called the Haber. By the way, Hao Ping, can you remember the name of the process for making nitric acid? I know I can. It's called can you remember? Go on. Go on, Hao Ping. Don't Google it either. You are like the world's fastest Googler. Can you remember? Is Hao Ping still there? I've got to ask. I've got to wait now. I've invested. I've invested my time. I've got to wait. Got to wait. Begins with an O. Come on, Hao Ping. Has Hao Ping just gone on break? Libby, throw it out to you because Hao Ping's gone. Hao Ping has abandoned me. Yes! Tiffany, smashed it. I'm not Hao Ping. No, I know you're not. Where's Hao Ping? Hao Ping should be here, shouldn't he? Hao Ping was here. Oh, I know. Oh, well done, Dom. It is the Otswald. Yeah, I don't think was it Ostwald or Otts? Oh, maybe I've got it wrong now. Wasn't it the Otswald? Like that with an OTS. Got to check now. Otswald. Go away. Wasn't it the Otswald? Or have I got that wrong? Oswald. Maybe it is the Ostwald. Ostwald process. It's Os. I'm an idiot. Yeah, there you go. I knew it was something. I knew it was close. Maybe he fast forwarded backwards. Yeah, I know. Probably. Yeah, Ostwald. Ostwald process. Anyway, sorry, I'm off track. Moles, grams over grams. Well, we realized we've got to convert to grams first. 4,000 divided by N2. Nitrogen's 14, but it's in a pair, so 28. Yeah, just to say that 14 times 2, we get that. And then we got this one, which is 500 grams divided by hydrogen, which is 2. 2. Well, this is going to be an easy one, isn't it, I think? 4,000 divided by 28 gives me 40. Whoa, it's massive. It's massive. 143 moles. And then that one's 250. Oh, it's closer than I thought. Oh, it means the ratio is going to matter. Ratio is 1 to 3. Cover somebody up. Cover somebody up. Cover somebody up. So 250 divided by 3 to get it to 1. I needed 83.3 moles. That was what was needed. Yeah. And how much do I have? Way too much. Excessaroni. Yeah. So there we go. Excess. Isn't that interesting? That, once again, the smaller is in excess. So we now write down 143 is greater than 202 moles. Moles when ratio. Yeah, when ratio used. I like that bit. Yeah. So there we go. So he's in excess. You ignore him. And then you use the limiter. So the ratio is 3 to 2. That's awkward. 250 divided by 3 times by 2 gives me 67 technically, 3 sig fig moles. Right, how much does ammonia weigh? Ammonia is 14 plus hydrogen at 1 times 3, so that's 17. Multiply that by 17. I'm using the number on my calculator, yeah, and I'm going to get 2,833 grams. And I'm done. I'm done. Right. Guys, I'm going to leave you be. I'm going to post on the classroom. I've put together some excess reagent questions for you guys to have a go at home, or just to help solidify it. Does anybody now at this point, would anybody like me to go over any of these? Would anyone like me to go through any of the 9 calculations types? Anybody like me to go through any before I leave you be and set your homework? You can do that. You can do the questions. There's only 7 of them, I think. There's only 7 questions on the work. What I'll do is I'll post that on the classroom now. Classroom. And go for 10A. And then classwork, create, assign. This will be excess reagents. Let's do these. There's only 7. File. Oh, is it not there? Oh, they're not there. Don't know why. Don't know where they've gone. Desktop? No. Huh. That's odd. Don't know where it's gone. There'd be excess reagents. Did I not save it? Maybe I did it on my other laptop. Totally possible. Is combustion on the test? Good question. No, it's not. I've not really bothered. Yeah, I haven't included combustion on it, complete or incomplete. I haven't done it, Libby. They're just all calculations. I've just done the ones which I don't know where that question's gone. Don't know. I'm trying to find it now, folks. Excess reagents on my other laptop. I'll post it onto the classroom, folks. I'll do that. I'll post that onto the classroom now for you guys to have. In fact, I'll do that. I'll do that on my other computer whilst I'm here. There we go. Classwork. Create assignment. Let's go. Excess reagent questions. Instructions. Do these. And guys, then you can have a look through your other homeworks as revision. At least I'm kind of there now. Documents, year 10 worksheets, excess reagent calcs. Done, I made one. Upload. Right. Yeah, good question, Libby. I haven't bothered doing combustion equations. I realized that there were so many calc types that was always going to be. I'll go through those next lesson. I put no date on the draft. There's a draft one. Delete. I'll delete that draft. Delete. There we go. So excess reagents are now in the classroom if you guys want to have a look at them. 7 questions are up there, and then I'll go through the answers to those tomorrow. I will leave you guys be. There's only 15 minutes left of the lesson. And you guys you can do some revision for the last 15 minutes. Have a look through all the homeworks that are on the classroom. If you've got any questions, let me know. And in fact, you can just ask me any questions tomorrow, and I'll go through any of the calcs types that you need me to. All right, guys. Have a good rest of your day, folks. See you soon.